I guess, yeah, we'll stay more to the research side given the audience here. But yeah, if there were business people, I was hoping to get them with that. So yeah, some things I did want to go for this. I'm still always looking for presenters. I know you both presented before. If you want to do it again, let me know. Be good to find someone else too. I don't know if there's anyone else in the area that would want to present. Oh, I was thinking we could sometime maybe have a cocktail night or something. I actually bought a lot of stuff for the 4th of July and only used a small fraction of it, so now I have a lot of cocktail mix and stuff left around. Something to think about. Probably will host something in August would be my guess. We kind of missed the month of June, but I was like traveling all over then. So yeah, we could have easily actually talked about this tonight, but currently the Kubeflow document sprint is ongoing, so I'm actually taking part in this sprint. It's basically, if you don't know Kubeflow, it's kind of this major platform to help train and productionalize neural networks, and in particular in other machine learning models at scale. So it's kind of open source framework, originally from Google, but now they've open sourced and a lot of people work on it. So these next 3 days, they're actually having a sprint where they're trying to close out as many of the backlog of issues on it as possible. So they're kind of having a cool event where you can join remotely and sprint on whatever issue you're interested in. And yeah, you do get like free t-shirts and stuff. If we were on the West Coast too, you could actually go to Google's headquarters and work on the sprint there, but unfortunately we're nowhere near one of Google's offices. So yeah, I'm currently working on some PyTorch serving code. So that was one of the things that were requested were more examples and tutorials. So I'm working on these tutorials on using Kubeflow to essentially serve PyTorch models at scale. But as I said, there's over like 50 other issues. Yeah, 44 a day ago, but they added some more to the backlog. So there's actually a ton of issues you could work on. And some are really simple. Like some is just like correcting grammar on the website if you're looking for something trivial. But, any kind of PR to, Google and Kubeflow would probably look good. Career perspective.
How many people work on this?
I think currently on the sprint there's like, we could actually look at it now, but yeah, I think there was around 40 or 50 people that signed up. So some of it's obviously actual Google people, but I think there are people, like I know there's some people from Italy working on it, some people from the East Coast. So I think around 50 or so in total, but they are trying to get like more. There's definitely enough issues to go around, so to speak. So yeah, of course, Kubeflow, as the name suggests, is built on Kubernetes. It's basically this Kubernetes-based platform for training and scaling deep learning models. Yeah, we might talk about that at the end if there's any extra time and people want to. So yeah, I'm trying to get my paper finished for iClear. I am looking for collaborators. If any of you are interested in co-working with that with me, I have a ton of code to rewrite and refactor. Also, the NIPS workshops are coming up soon. Some of those might be of interest to you. I know I think they think they're going to have one on climate change this year at Machine Learning for Climate Change, if that's something you're interested in.
I saw one of the listservs.
Yeah.
An email I didn't read, but something about AI and climate change.
Yeah. So yeah, you might be interested in that. Okay, so that's kind of the news. So agenda. So actually, there was a really good tutorial on pretty related to this topic at ACL, which is a big natural language and processing conference. So I am going to use from that a bit just because it's really good initially to kind of introduce things. Then I'll discuss some of the more recent things that weren't included in that, specifically MTDNN and XLNet. And we'll look at some actual code examples, maybe a code walkthrough. And then, yeah, we might look at how this relates to how we could deploy some of these NLP models on Kubeflow if there's time. Okay, so the first part is actually this, as I said, this tutorial, which was put on by Sebastian Reuter and some of these other people at NACL, which was a conference in Minneapolis. Yeah, this is just, I found to be a really good kind of tutorial. And so I obviously didn't want to just recreate my own less good version. So yeah, so this tutorial is on transfer learning and natural language processing. And it's actually really long, so we're not going to go through the whole thing. I think there are like 230 slides, and this was over like a 3.5 hour conference, or 3.5 hour block. So obviously we're not going to go through it. But I'm just going to go through some of the basics to kind of introduce some of these ideas.
Is this something that will come up with Google?
Yeah. So yeah, I'll also post this. So are you both familiar with transfer learning? So yeah, we can skip through that. So this is kind of a good thing of like good overview of transfer learning and NLP, kind of from dating back to it's the F1 score on data sets.
Oh.
So make that screen. So it's the F1. So yeah, this is kind of a overview of how things are improving in terms of named entity recognition, particularly recently. So this is BERT, and this is the model we're going to talk about a lot in a bit. And this is just one task named entity recognition, but it's probably even more so true on more complex tasks like question and answering. So yeah, there are a bunch of different types of transfer learning. So yeah, primarily most of the BERT models and others leverage sequential transfer learning. Yeah, we don't need to go through all this. This is abbreviated. So yeah, I will just talk about this really quickly. So one of the things that one of the big breakthroughs kind of in transfer learning, so to speak, for NLP is kind of these pre-training models on very, very large data sets, like the entire Wikipedia corpus and things like that, and then basically taking models pre-trained on all these kind of documents, thousands of, well, even millions of documents and even billions of words, and then fine-tuning them to a specific task. So that's kind of what that's talking about. And then, you know, usually with transfer learning, then you have a specific target task you're aiming for, like say sentiment analysis or question answering. We don't need to get into all the details of that. So yeah, this kind of reviews how like earlier models were just kind of very shallow learners, and now we're getting into really deep neural networks. So are you kind of familiar with word representations and things like that?
Maybe, but I'm not sure exactly what that phrase.
So basically the idea was that based on a context, whatever words surround a word, like you could obviously start off just by representing words as kind of like a vector based on adjacent words, a word to vect, and then like we had going into more advanced things, you basically would train a neural network to actually on text to predict the next word, and by doing that you could get word representations out of those kind of hidden states of the neural network. So this is kind of an overview of how some of the different models work. The latest is BERT, where they actually, instead of just masking, say, the end word, which was kind of, people did a fair amount, because that was actually, though, kind of problematic, because if you just mask the last word in a sentence, you only had the contextual information from the left part of the sentence or something. Whereas if you mask actually a middle word, then you can leverage both the left and right contextual.
What was symbol? Was the circle with the two like orange dot symbols actually?
I think that's supposed to represent a vector. It's kind of visualization just of the word vector.
The arrows, so like in the bird picture, the arrows on the top where they go back and forth, they're like reciprocal connections.
So this is yeah, bi-directional is what it's saying. So it's incorporating information from both the words on the right and the left. So if you look at like skip saw, it's just incorporating information on the words on the from the left of the word, whereas here it's doing it from both directions.
What's the we like pets?
Oh, but that's like external information or something.
Oh.
Yeah.
We like pets. Okay, so it's
We have a
pet
pet.
dog.
Yeah.
Okay.
Yeah.
Or something.
Yeah. So these are, so then they run for kind of word vectors and unsupervised pre-training clusters. This is kind of related. Then this is actually a good area for current research. So BERT and some of these bigger models have, well, you can always get better, but they've created very good word representations. What's more iffy is creating longer document representations at this point, which is actually something I might be looking in. But in theory, like word vectors are very good for like clustering similar words, but it would be really good, for instance, to like take like document vectors and say cluster documents in a similar way, or even like have general kind of purpose document embeddings, because that could affect a wide range of things, from like say taking like free form medical text and clustering patients for downstream tasks, or even taking like historical documents and seeing if you could group them based on specific attributes. So yeah, document stuff is kind of, document embeddings is kind of an ongoing area of work. I do have some ideas on that, on training maybe models for that. But it's kind of in general much harder because obviously words at least, like you would capture the immediate contextual information. Documents, there are a lot of subtleties, but one of the ways you could go about it is by first taking word embeddings, then creating a tension kind of between them, and then creating an all-around document embedding. And usually you could do that for document classification. So you train a model to do classification, then you would have look at the hidden states of that, and you might have good document embeddings. But really, there's more to a document than just one label, so that's kind of where that goes wrong. But anyways, so they talk about some of these. This is kind of an unsupervised method. We're using autoencoders. Basically, any type of embedding can be generated by feeding data into an autoencoder, because it tries to essentially replicate its own output. Well, replicate the original input in the output. So, but I don't think autoencoders have worked all that well. So yeah, kind of an intermediate step between word embeddings and full document embeddings would be sentence embeddings. So here they list some of the recent research on that. So this is talking about contextual word vectors and like how like the embedding of a word should depend on like what what context it's used in. Obviously, a word can be used in many different contexts, so they're just looking at the contextual embeddings and how words should be. The model should basically make the words when they form the embedding be context dependent.
Does any of the modern NLP stuff utilize like real grammar constructs, or is it all just looking at like the context of the word and other words sort of blindly?
Some of them do use rule-based methods. There have been some papers on synthesizing like rule-based and linguistics things, but they haven't been as popular as these just kind of training on massive amounts of text and seeing if the neural network kind of learns by itself the kind of rules.
That's what because before neural networks took off, that was the huge like NLP thing, was like trying to piece together words and sentences by first feeding them through like some understanding of grammar or something like that to determine what role they played in a sentence, or at least partially.
Well, that's kind of interesting because the Grammarly, I think it's the program.
Mm-hmm.
It's kind of interesting because I don't think that they do it that way. Grammarly is a grammar detection software. I don't think they, like, I think, I don't know how, but eventually they have to match it up to some kind of rule. But I don't think they do it the old way.
I don't know. I have no idea.
Yeah, and it might be a mix of the two. So they might like leverage deep learning and then like maybe use a hybrid method. Because you can do that. There were things on like there was like a paper recently on marrying up regular expressions with neural networks or something.
Yeah.
Somehow like creating like embeddings from like regular expressions and combining it with word embeddings or something. So there are some like synthesis ones.
Well, that's the other thing, is that if you emphasize the grammar, then if you don't emphasize the grammar, if you emphasize it, then hopefully your training can use the same rule, the same call it technique for different languages, right?
Mm-hmm.
As long as it trains.
Well, that's the idea. It's just repetition of patterns and learns by just seeing these patterns.
Yeah. So
When I took it, I remember doing the grammar based stuff. That's how old I am.
But it's still good shit.
Yeah.
So here's kind of an example sequence to sequence pre-training. This is basically just stating, basically sequence to sequence is when you have an input sequence and then you're trying to predict an output sequence. One of those examples would be, say, like named entity recognition, where you have a sequence and an input sequence, which would be a sentence or something, and you're trying to detect all the named entities in that. So what they're saying here just looks like that unsupervised. So by unsupervised pre-training, even without definitive labeled examples, it seems to result in boosts for machine translation, it looks like. So MT. So then Cove, I don't know what Cove is. Looks like it was probably some type of model that preceded BERT and some of the other things. But the first one that was kind of really started this whole trend of transfer learning models was Elmo. So there was to pre-train these bidirectional language model. So basically, this is bidirectional, so it incorporates both the left and right context. And so you have these LSTM cells, and it basically achieves, then using these word embeddings, it was then achieves state-of-the-art results on 6 diverse downstream tasks. I don't know what exactly those were. I think they were question and answering, maybe sentiment analysis, but yeah, in language modeling and stuff. So after that, there was Oldfit, which was kind of multi-stage LSTM, and it kind of improved, was kind of a better version of these Elmo embeddings, and then it worked really well specifically for classification, for pre-training for classification and fine-tuning downstream. And then there was GPT-2, or well, GPT, then GPT came later. And so yeah, this basically started using the transformer architecture. Remember that we had the attention meetup? Do you remember any of that? We talked about self-attention and all that other stuff. But anyways, the transformer mechanism essentially incorporates self-attention. And so this was kind of one of the good uses of attention, was that in particular attention was able to, the self-attention mechanism was able to generate better word embeddings. And we see this later in BERT too. Okay, so now we finally get to BERT, which came out last October, but already it's kind of old, but it's still very majorly used. And it's kind of the basis for these ones to come. And so the biggest thing it was trained on like a huge amount of data, but then it could be fine-tuned to other tasks, like Squad is a question and answering data set, named entity recognition, and other things. But it basically used this transformer architecture with these masked tokens and things like that, where, you know, masked certain tokens and fed them in, then ran them through a transformer model, and it was able to produce very good kind of generalized embeddings. But as I said, it was a huge, the model itself was huge. It had 340 million parameters and 20 layers, it looks like, and it was trained on a huge amount of data. So these were all these various tasks in NLP, and you can see BERT essentially set the state of the art pretty significantly. Even though these are only slightly higher, this is pretty big in terms of NLP, where things just move forward slowly. So this was in question and answering specifically. So this is the Squad data set, which is a question and answering data set. I think we might have talked about Squad once before too at a previous meetup as well. Okay, and then this was the cool thing too, pre-training, as you might expect. It reduces the need for future annotated data. This is just with Elmo embeddings. So those are the baseline. Yeah, it needs less annotated data to achieve better performances, essentially.
Is that almost like how much less it needs?
Yeah, I think so. So that's like 1%. So yeah, I think that's with 1% of training data, the accuracy, and then all the way up to with 100% the accuracy, and then the dotted line is the baseline method without pre-training, whereas with
looks like, at least in the left one, was like 9%. You like the pre-training kind of doesn't make much. There's very little. Is that correct?
Yeah, with at least yeah, with at least Elmo and stuff. And that's in one task. I forget what SNLI actually is. It might be helpful. So yeah, SRL, it looks like it makes more of a difference even towards the full set. That stands for semantic role labeling. Forget what SNLI is. Oh, I guess it's the name of a natural language. So it's an entailment. Yeah, it looks like for entailment. Oh, okay, so yeah. So these are kind of examples from the data set.
In some East Asian country, the man is sleeping.
Okay, so I think it's, yeah, to predict this. It's like basically a classification problem that given a text in a hypothesis, it then labels it as a contradiction, a neutral, or entailment. So that's so here's some other things on the UML fit, which, so validation error rate, number of training examples from scratch. So yeah, I think on pretty much all the kind of Oldfit tasks, it basically kind of fairly significantly reduces the number of training examples needed. Even through, it looks like even through like, up to, yeah, was it 20,000 examples or so? At least on this one, it maintains an advantage. I don't know exactly what these tasks are. They probably should have labeled them, but here it looks like it's closer, but you can see it kind of does reduce the need for large numbers of examples. I'm just quickly going through, seeing if, okay, so some of these might be interesting. So these slides talk about some of the actual code you might use for pre-training GPT-2, BERT, and things. So, here's kind of an example of that. So there's a transformer architecture I was talking about before. And, as standard PyTorch, you have a forward operation. And it looks like what here is here. Yeah, I'll make it. Yeah. So yeah, it's basically just saying you have an embedding, yeah, normalization, attention, dropout, and then a normalization, feed forward, dropout. So yeah, this is the transformer essentially. The transformer is composed of essentially self-attention layers and normalization and dropout. And yeah, there is still, you can definitely go back and review, like I know there was the meetup in March, we did talk about self-attention and actually in detail what self-attention was doing. But yeah, that was actually a critical kind of part of the transformer architecture, was the use of a self-attention mechanism. Yeah, I guess so. So, oh yeah, so this is nice. Does anyone actually like know how to make that in slides where you like have the arrows highlighting stuff? Does it just take a lot of time and energy in Keynote? But
I know how to do it in the Tech Beamer.
I always thought you just made like the second slide.
I have some examples of it in the Tech on GitHub I put on because it was kind of it's a pain in the ass.
I'm a minimalist when it comes to any kind of presentation. If I put words on it, that's good for me.
yeah. So yeah, it looks like those are the actual parts of each operation. Yeah, we don't have to go through all of this, but so yeah, this is talking about the tension masks. Yeah, this is somewhat similar to yeah, what we talked about in some of the self-attention things, but the attention mask will basically focus words and the importance of words, and in this case, creating the context of other words.
So the attention, this sounds a lot like in long, short-term memory, that sort of forgetting mechanism. Is it sort of the same thing when you have like the vector that you mask the current state to reduce or forget what's coming in the input?
Yeah, it's kind of an alternative almost to like RNNs and the hidden states. So you, instead of that, you have basically a layer that just learns like specific areas of an input sequence and how they relate to an output sequence.
It's like almost like a convolution in a way. Just
Yeah, it's similar to convolutions. Actually, there was a paper recently that argued you could replace a lot of types of attention with specific types of convolutions. And then, yeah, specifically in this case, that this is what's known as multi-head attention, where there are multiple kind of attention on positional encodings, and then each head learns different relations, essentially. Okay, so yeah, I don't want to spend my whole time on these slides, but
Enough of these slides.
yeah.
The slides are bullshit.
it was good, but now I'm sick of it.
Yeah, so yeah, we'll talk about some of the more modern, so we can move on to some other things. So MTDNN was kind of then building a multitask learning for doing a variety of set of tasks on top of BERT. So it uses kind of these BERT kind of layers to originally process things, but then it has task-specific layers. And then so it alternates training between tasks, which is kind of actually odd for multitask learning. Usually you do all tasks at once, but here it actually alternates training with mini batches. So this is kind of what the architecture looks like.
Why does the alternate? Why does
Because you don't have all the annotated data in one data set. So unfortunately, so that's why it has to alternate. Otherwise, it would be really nice just to do it.
that sounds just like
Well, yeah, it's a data problem. They don't have all the data set with all the different things. So it has task-specific layers. Some for single sentence classification, pairwise text similarity, classification.
That's a problem that doesn't go away either. No. I mean, you're always going to have malformatted and unannotated. You're not going to have it the way you want.
Yeah, we were talking about that earlier. Actually, about that data is like, forget all of this algorithmic bullshit. The kings of the world and people who have these perfect little data sets that everyone wants to train, their tanks to blow up other tanks or something like that. If you have that shit, then you're a billionaire. Who cares about the algorithms?
Yeah, well, and this this data set was actually made as kind of a synthesis of different data sets. So actually, there was like, they took some data set was publicly released from Quora in terms of textual similarity, and they took another data set which was sentence classification, and they all stuck it together as kind of one benchmark, but none of the labels overlap between the data sets, obviously. So hence the need for kind of that iterative batch, where each mini batch is from one data set, even though it's multitask learning. So yeah, so here you have kind of this. So the shared layers, this is essentially just BERT, another way of showing it, and then on top of that, then you have these multitask training layers. But this is a good example of then given new input data, then you could potentially do all these things in a multitask format. And this did, for a short time, hold state-of-the-art kind of performance on this, what was called the glue benchmark. So that was good. Then later, as we'll see, there was a even better model that came along. But actually, this could be widely applied to new models too. So say someone creates better word embeddings, then you could just take those as the base model, kind of throw out the shared layers and take those, and then still maintain the task-specific layers. And it'll probably achieve even better performance. So that's kind of what happened with XLNet. Oh, I didn't format this right. Yeah, I messed up the sequence of that. So yeah. So yeah, that should go out as one. That's okay. And then, well, I should have. Anyways, this improved on BERT's performance, though it cost a ton of money to train. It was an estimated $245,000 to train. Of course, it was trained by people like Google, so they probably didn't actually have to pay that cost, given it's their own hardware. But if someone like you or me wanted to train this from scratch, that's about what it would cost. Okay. So basically, one of the big steps in this was they incorporated two-stream attention. And so basically, one of the problems with BERT, I didn't spend enough time on that slide, but anyways, one of the problems with BERT was that when it masks things, it kind of created these biases. So one of the ways this handles that is by explicitly, I think, encoding the relationships between masks, particularly if you put multiple masks in a sentence, is that not having the downstream mask affect, the sentence, the different masks, since it's bidirectional, not affecting each other. So this is kind of what this two-stream attention did. I'm not sure exactly how it works. I haven't read through the full paper, but it did achieve kind of these new really good results. And it basically beat out BERT. And this was kind of released just less than a month ago, so it was only released like 2 or 3 weeks ago. Okay. So demos. So another big one of these interesting ones that actually generated a lot of media hype too was GPT-2. Primarily because it was really good at text generation. So we kind of looked before at the GPT model. The GPT-2 is essentially almost exactly the same architecture, but it was trained on a much larger data set. I always say it's more of a data engineering effort because they essentially scraped a giant amount from Reddit, Wikipedia, and a bunch of other sites and create a bigger thing. So this came out in February, and OpenAI, and what I think was pretty much a publicity stunt, specifically said they wouldn't release the full model because they thought it was too good at text generation and it could be used for like bad actors to spread misinformation. So yeah, it's able to generate these long samples. The long samples, if you actually read into a lot of them, they really don't make a lot of sense, as we'll see in a second, but it can be fine-tuned to like generate at least somewhat grammatically correct sentences. I think this is so like given a prompt, it could generate, say, a model completion of the prompt.
It's like that text that spam used to send you, spam emails that would pass that.
And but yeah, this was kind of a big deal, and then there were a bunch of articles like about, this is why I think it was a publicity stunt, because then a bunch of other news sites released the AI models that's too dangerous to release, and you started getting a lot of these headlines around and stuff. And then yeah, shortly thereafter, OpenAI. Yeah, they did another round of funding or something. So,
Yeah, exactly.
anyways, luckily some people, OpenAI finally did release one of their medium models, and some other people refactored some of the TensorFlow code for actual training and fine tuning. So now we have this nice repo that I'm using.
They're the ones that wouldn't release it.
Well,
yeah,
they fall into this category of ethical AI people that believe that there should be these AI gurus around the world who keep watch on what's dangerous and what's not dangerous, so that they can explain it to everyone else. Because of course, I know AI, but I sit here and watch all of these like 3-letter acronyms and 5-letter acronyms fly by and have no idea most of it. Give all this stuff to a congressman. They fall into this category. Specialists must be the gatekeepers.
That's a good point. Who advises Congress about technical things?
Mark Zuckerberg.
Yes, we need it to be the heads of all the largest companies.
That's always what it is.
Yeah.
If it's the oil, it's Exxon shows up.
Yeah.
So there's one scientist sitting at the end who says it's all bullshit, but no one listens to him.
Yeah.
It's correctly here. I pulled a t-shirt.
Yeah. What do you mean you gotta remove lead from the gasoline? Your kids are fine.
So yeah, naturally though, like people like took some of the code, rewrote it, and people released frameworks despite OpenAI's thing about not releasing their code. So there's now this nice actually repo you can kind of install called GPT-2 Simple, and it comes with kind of a medium-sized version of the model, so not the very best version of the model that they trained it on. I think it's like 345 megabyte version of the model, which is the actual size of it. Then there was the 1 gigabyte, which was trained on the billion of things. But it's still like originally they only had a like 10 megabyte version. So now it is getting bigger. But so yeah, I kind of wrote this code, and so now you can actually train it and fine tune it to generate stuff on a specific subject. So we'll look at how to do that here. So yeah, I basically I'm primarily using this repo. And so what this is going to do is there's this fine tune function, and it's going to fine tune on a text file for a specific number of training steps. And the idea is that by doing this, then it will soon be able to generate stuff in the same style as your input text and things. So,
you give it Shakespeare, it will produce
Shakespeare light.
Shakespeare, crazy Shakespeare.
Yeah. Shakespeare on what is it? The absinthe. Absinthe Shakespeare.
So
Or you say monkey?
Yeah, there's that one thing that says you put a monkey in a room with a typewriter, he sits there for all eternity, so you're like real type hamlet.
Yeah.
That was like the olden monkey joke.
So, yeah, I probably won't go through a full training cycle, well, fine-tuning actually cycle right now. But here is kind of an example. So there are all these, so where's my actual code for that? So yeah, there are all these sports stories, for instance, from the BBC. And so basically if you train it on this and fine-tune it on this, it will create like sports, like it will generate a bunch of sports like text. So just combine text. Oh, I didn't find that. So yeah, fortunately these are as separate text files, so even now I had to write pre-processing code to put them all together. Actually this was a previous training session, and if I ran it again now, this is kind of what it looked like. So these are kind of the initial samples after kind of one full iteration through the file of what it generated. You can see like even at this point it's beginning to kind of integrate some kind of sports lingo and stuff.
It's not good. Scroll to the right. All right, it's not about the money. It is about what we are making. I have said to the kids, don't go to school when you are young. And don't go to the university. Keep scrolling before you find your dream place. Okay. Sage advice. Don't go to school when you're young.
Go to school when you're old. That's when you have time for it.
Yeah.
Yeah, then after several more training iterations, this is some of the stuff it produces. It's kind of like more real. I guess it's kind of a bit more realistic to what like sports writers might write. So yeah, you can kind of see with like fine tuning how it does begin to fine tune to kind of represent kind of what these texts would be like. They're like still known. These are really, if you look at them closely, sensical, but one or two sentences on their own could, without context, could be.
So the fine tuning, so you have the model, and then the fine tuning is what's going on with the fine tuning.
So in this,
just like vocabulary type, like with the words.
So for the fine tuning for OpenGP2, it's basically taking this text and essentially the text we're putting in, which is the concatenation of all these different stories about athletics, and then like feeding that into the GPT-2 model. I'm not sure if it's modifying all the layers or just like the final output layers, but it's essentially, you know, continuing the training process, but with a specific kind of subset of data related to one specific domain instead of the kind of the generalized data it was trained on.
So it must.
So how do you specify that it's sports? Or is that...
Well, here I just if you look at this, is basically just pre-processing code. I downloaded this code from.
Feeded a bunch of sports.
Yeah. I also had, what was it? Another one where.
But how many stories was that? It looks like that.
Well, it's a bunch. So like each one of these text files represents their own story, and so yeah.
And how many training iterations does it work? Like, is this a really fast process fine tuning, or is it like a really long training cycle?
This took a couple hours running. It took an hour and a half or so running on one GPU. So it's not that. So it's pretty fast relatively to fine tune it. It doesn't take like all day or anything, certainly.
$250,000.
Yeah. So yeah, that's the kind of GPT-2 example. So there is an example using the pre-trained XLNet to fine-tune for sentiment analysis. I don't know where I put that. Locating Drive. Do you use Google Colab at all?
I use Google Drive. I mean, you just need Google Drive, yeah.
But have you used the notebooks here? They're pretty nice to actually give you like free GPUs if you use these Google notebooks and stuff. Real time.
I know that with I started using it even to store. I started with large amounts of data because technically it's like we have limited amounts of storage to this full.
We have unlimited.
I think on Google Drive we have like practically unlimited storage.
Oh, that's interesting.
Yeah. So I mean, it's super slow. I started uploading some data sets that I wanted to just save forever. It's like 10 gigs or something. 2 days later, it's still upload.
That's funny.
Remember?
Is Google storing it, or is it?
No, it's Google. It's just Google Drive account with your email.
Okay. So this is the fine-tuning XLNet example I actually found directly from their website. So this is actually pretty much their code. But basically this takes essentially XLNet and fine-tunes it to do sentiment analysis based on this data set of essentially movie reviews from IMDb. So yeah, we can actually try. I think it takes a while to train, so we probably won't get through training it tonight. But we can kind of run through and look at what it's doing. So yeah, it looks like first it's installing some sentence piece. This is the this is the actual XLNet download. So they're obviously storing it in some Google bucket. So this is the essentially pre-trained model that we're downloading of XLNet. The one that cost all the money too. Yeah, and it looks like it's a pretty big model, even stored. It's about, what is it, a 1.2 gigabytes model.
Where can you use it? I don't know. It wasn't here.
The bar, like next door, or is it somebody upstairs? Apartment upstairs. These notebooks are so nice. Like the way that intermingles the documentation with the actual code. It's really nice. Do you use any org mode?
No.
Org mode is kind of that way. Or Emacs. It's Emacs time, really.
Yeah. No, I don't. I'm a pretty non-power user of Emacs. From time to time, I do some stuff. But
So that was the train command. So it looks like, okay, yeah, I think it's starting training now. Yeah, again, I probably won't finish tonight. Well, I mean, probably while we're here, I think that they said it takes 2 hours or something to train. But that's how you would kind of train it for sentiment analysis. But what we could do, I guess, here we could actually add TensorBoard. Yeah.
So this command here,
So this is actually, I think they're creating a Linux command, and then they're like having it call the Python code.
Oh, I see.
So they're wrapping this into Python, XLNet, and then these are all the different parameters. So the, yeah.
I was like, is any of this like Python code, or is it just running shell stuff? It is.
Yeah.
That's cool. That's cool.
Yeah, and what it's doing, it's like we can actually, maybe while that trains, look at what's on the actual Python code is. So it's basically cloning this repo on GitHub. So GitHub, this is the actual XLNet release of the code, which is here. So generalized pre-training. So yeah, I have to admit, even though it cost them a ton of money, it was really nice. Unlike with OpenAI, they actually released all their code and all the weights, which is good. So yeah, and then there's actually pretty extensive documentation here too on how to fine tune it to different tasks. Info on the max batch size, the sequence length, using it for regression and classification. So this is what we're using it on the IMBD stuff. But there are a couple other ones. This is Squad, which is the question and answering data set. So you can find it, tune it on that. Race. It is actually also bubbled up as a package. So actually, I think if you wanted to do something like with the MTDNN, except built on top of XLNet, it wouldn't be that hard. I think you basically take this sequence output, or you could take this XLNet model and then just add a couple layers to it here, and then which would be the task-specific layers, would be my guess. Though I'm not sure on that. So this is all also TensorFlow code, in case you're wondering. So this is a bit different than PyTorch code. So it's this run classifier, which is actually running for IMDb. So this is the actual Python code it's running to train it. These look to be all kind of flags and different parameters you can use. Training, input example. So they actually have a class for that. Oh, and this is the glue. So this is the thing to process the glue data set. Yelp. So these are basically different data loaders. And yeah, it really is telling, when people say, oh, I spend the majority of time writing pre-processing code, it's kind of true. If you look at this is like 300, 400 lines of pre-processing code pretty much.
I wonder,
why is everybody writing pre-processing code? Why isn't it just written once in the data set published?
because nobody agrees on formats of anything. Which is okay. I'm actually a big, I used to think oh, you have to make sure everybody has the same format, or you have some master format that has all the metadata that describes it.
Yeah.
I don't think that's the way to go anymore.
It's not impossible, because if you just change what you want to do slightly, so that someone else's master format doesn't work.
Exactly, yeah.
No such thing. But still,
I'm actually more of an advocate of it's almost like duct taping. Saying you look at a data set and you say, does it have this thing? And if so, then I'll say, all right, we can use it. Otherwise, you have to feed it through something. But once you say it satisfies these conditions, then you can use it for this thing. And then so there's I write a program, I say, I just specify the conditions that your data has to meet.
You're talking about preconditions and
preconditions.
For data itself.
Yeah, for data itself. Yeah.
Section. It was part of preconditions, but obviously software verification stuff.
Yeah. That's exactly what I'm talking about. From that same idea, except apply it to data sets.
So yeah, this is still running. It looks like they are printing out the loss, the various steps. Yeah, there is probably a way we could put up TensorBoard with this. I don't know. Have you used TensorBoard before?
No, it's been such a long time since I've done anything with TensorFlow. Like the amount of tools to go along with TensorFlow now, it's way beyond me.
Yeah, TensorBoard is nice. I usually try to use it. All you need to do is basically pass in the checkpoint directory, and then you can should show you like graphs of the loss and other things like that. I don't know exactly where they're writing the checkpoints though too. I have to figure that out. I can also see it looks like our RAM usage is really high, almost running out on the notebook. Yeah, they actually said, I think, like an old.
You gotta use it, right?
Well, unless you.
I mean, garbage collection is expensive, so if you don't have to collect, don't do it.
Don't do it. Well, it's fine if you want to do nothing else for the next 2 hours, but have this run. Yeah. You want to watch a movie while it runs. So in the context of transfer learning, which you started off with, in this context, transfer learning is the transfer from the pre-trained data set to the pre-trained model to these fine-tunings. Or is there no, are we not talking about transfer learning?
Yeah. So the transfer learning is we're creating kind of like these general multi-purpose word embeddings by training on this really large data set. And then we're taking those embeddings and then essentially creating fine-tunable layers.
Final training set.
Yeah.
Okay.
This,
So it's like one node and then you can multitask out from that centralized.
Yeah, so here we're fine-tuning it to now sentiment analysis, but you could fine-tune it to a bunch of other things too.
And there are a lot of people looking at, so this the core model is trained on just a massive amount of whatever Reddit scrapes, stuff like that, for no general task in mind. Is that correct?
I mean, it's being trained, yeah, just to create universal kind of embeddings that could be fine-tuned to any task.
And is anyone working on something like, well, if I train it to do like a second transfer learning, like if I train it on sentiment analysis, is this this fine-trained model, is that then usable as another basic embedding for then you get more power out of doing pre-training and then using that as something to pre-train again, sort of incremental steps.
Yeah, lots of pre-training. I mean, sentiment analysis will kind of modify it a bit towards that specific task. So if you're not doing sentiment analysis later,
or for not making sentiment analysis, for like when you did sports stuff, where you recalibrate what it's focused on.
Yeah, you could definitely continue to training, but in general, like even with the sports stuff, we're now training it in like a specific domain. So by doing it, it's kind of lose some generality. But say if you were continuing to maybe look at just sports down the line, then definitely by fine tuning it to that, then that would be good for basis for more stuff with sports.
It sounds like most of all of these like plethora of models that seem, by what you say, come out like every 6 months. It sounds like there's the latest hot shit. It's all focused on that first stack of taking the raw data and using the general model.
Yeah, that's what a lot of them is focused on. Because, and also because just in general, you know, as it's a good way to like get your name out there and stuff. Because like you train a, even if you like say you like create a specialty model for sediment analysis and then say a state of the art on that, that's not as big as like saying a state of the art for like 10 different tasks or something.
But it now sounds like that for the average researcher who isn't backed by Google or perhaps at Carnegie Mellon, these general models are, you can't do them. Like you and I can't do these models.
Yeah, we definitely don't have the money or resources. So we have to focus more on kind of these either fine tuning to a specific new task or kind of looking at like maybe other methods of fast adaptation to new tasks and new things.
So I read an article recently about that, just the general trend of AI. And big steps in AI now require so much processing power, hardware to prove that your idea, like, so like, well, I think if we, you know, have the input skip every other step, or so you come up with some tweak you want to do, like in order to prove that this is something that's going to get some benefit. It's unless you've got a gigantic grant or work at Microsoft or something.
Well,
The average researcher can't do it.
it's also part of the problem with the dark arts. You know, like if you want to go down where it's difficult to say why things are happening, but it works.
Yeah.
Like,
You know.
Well, and actually with XLNet and stuff, it's interesting because the actual base architecture, which XLNet is based on, came out a while ago, and it was basically this transformer XL model that combined kind of RNNs with attention. And then BERT came out, and it was kind of the big thing. And the XLNet researchers, I don't know why, but despite some of them were at a university and some of them were at Google, but initially they didn't have the computational resources to test it against the data set size of BERT. And it was only actually then like 6 or 7 months later when they trained it on a similar BERT scale of data that then, you know, their model came out as the state of the art. So there might actually already be like different small tweaks to the transformer architecture or even self-attention. You know, there are things like reinforced self-attention, which on small scale language modeling tasks are performing better and stuff, but no one has the resources to train them at that scale until someone, you know, like Google takes up one of those models and blows it up onto this data scale. But yeah, so I think for like the average researcher who doesn't have tons of these resources in NLP, the new direction really is like looking more at sample efficiency and like taking, maybe starting from one of these big models, but then looking at like specific tasks or like building complex tasks on top of that and looking at, oh, can I fine tune this to a new task with only like 5 or 6 examples? Or how does meta learning work with this or something like that? So like some of the stuff I'm actually researching and now is actually then taking these kind of general embeddings, then sticking downstream layers for like task-oriented dialogue on top of them, and then like using training the downstream layers on a bunch of kind of task-oriented dialogue data sets via meta learning, so then basically being able to adapt those to new tasks type data sets with only a few examples. So it's almost kind of like a double layer thing where we have the very general pre-trained embeddings, and on top of it we have the meta learn embeddings, the meta learn kind of task-oriented dialogue layers, which then can be rapidly adapted even faster, only based on like hopefully 5 or 10 examples. So.
yeah, you know, I could see. I'm trying to like think of examples, like with climate changes, that you could use this, and if you had a big collection, if you like took like a bunch of climate, well, not even climate like papers, it probably would be more useful would be not climate papers, but something like historical papers and books and geological stuff. And I think what would be really interesting for like climate change researchers would be if you're looking at some data and you see some spike somewhere at some year, and like you want to somehow extract, you want to like find related events that could help explain like that spike. So like the Industrial Revolution like caused a whole bunch of things, but then there might be like other things.
Like a factory blew up in Scotland.
And obviously it's easy if the paper, whatever, is like in 1850 and you're like looking at 1850 like, but like what would be more difficult is like extracting things that were related or around or like maybe span way through like long range over it, you know what I mean? Or
yeah, well, it's also maybe like a double jump. So like, let's say you don't know, you're researching climate, and you don't know that there was a volcano at some point.
Volcano.
So maybe you didn't even know that this volcanic eruption could affect what you're studying. But you run this stuff through one of these, and then make that connection. This thing affects A, and A affects the thing I'm looking at. I think that's a hard problem, like cross-domain knowledge.
Yes, that's exactly
Well, there is a data set called Hotpot QA, which is a data set for explainable multi-hop question and answering, which sounds somewhat similar to that. So basically where were some of the examples? I know they had so yeah, multi-hop reasoning. So like there might be so this is basically the format of the data set. They like give the model like 2 paragraphs, and then it is asked a question which it will require essentially knowledge of both paragraphs. And so here's kind of an example. So it's kind of this multi-hop question and reasoning, which can be useful for a wide variety of things, as you could imagine. And actually, so the model is now performing best on this is one of these called multi-QA, but essentially multi-QA uses BERT as kind of the base layer again, but then essentially does create like a question and answering layer on top of BERT, which then it even fine-tunes the question and answering layer on a bunch of question and answering data sets, including News QA. And then, so these are all the different data sets: Squad, News QA, Search QA, Hotpot QA. And I think it gets like the best score on it by doing this BERT, kind of going from a very general kind of the BERT embedding layers then to the still general but question and answering focused multi-QA layers, then to the very specific kind of Hotpot QA data set.
What's the wiki?
I think that's similar to that. It's like there are a lot of question answering data sets, but reading comprehension with multiple hops. So this is a kind of example, I guess. The first of the 2 data sets is open domain and based on Wikipedia articles. The goal is to recover Wikidata information by hopping through documents. So, yeah, I guess here you'd have like.
It's in the Gulf Coast Plain. The Gulf Coast Plain is in the southern U.S. The U.S. is in the U.S.
Yeah, I mean that's the type of thing that we're just talking about. How do you know something affects something else or comes from something else. I mean, that's,
Yeah. I don't know.
Yeah.
I think at the end of the day, it's like, you know, a lot of this stuff just end up in search engines and, like, you know, that's
well, are we using, for a question and answer right now, like what is Google using? Is it using this type of thing, or is Wikipedia using this type of thing?
Google, I think, well, both Google and Bing, I think, use an ensemble of different things. So I think they do use some neural networks, and then some more kind of traditional rule-based methods. And then they basically, and in some cases, they might even be like running like A/B tests with it. So they might like direct a percentage and then, you know, see which performs best and stuff like that. But yeah, I think Google definitely at this point is using that in question and answering. I know for Google Translate is entirely neural network based now. It's like now 100% based on that.
it's getting like, scary good. Google Translate, I have to say. In a lot of cases, it falls down. In a shitload of cases, it's like, whoa, that's really good. Compared to like the first time I saw it, where it was awful.
Yeah, of course, one of the big things with that too is like Google Translate, like they've open sourced a lot of their translation models, but they still have this huge like proprietary data set that like for translation that no one can get their hands on.
I think that comes out of that whole Google Books thing. Like, I think that contributed to their data set where they consumed all of those books, and then they were going to publish them. I mean, you can see a lot of them on the internet, but it's like you get to read so many pages and it cuts you off for like every third page. And I think they were like sued or something that they couldn't do it or something like that. They'd scanned like millions and millions and millions of books.
Yeah.
I wonder if that's where their data set comes from.
Yeah, it definitely could be. Sure. But, and then another thing I was saying that was interesting, and I'm looking into too, but might require more computational power, is I do think like we now have really good word embeddings. A good thing to look towards would be document embeddings. So what I was thinking might create good document embeddings might be actually, so a lot of the times they're kind of made by doing document classification. I think actually if you took a multitask model and had trained it to do document classification, questioning, and answering on a document, and summarization of a document, I think that might produce a much more generalized kind of document embedding, which then could be useful. Just off the top of my, I haven't tested that at all, but that's something I might pursue researching. But I think that could take, like for instance, if I tried to do that on like Wikipedia or a bunch of data sets, that would probably require almost as many CPUs, some of this other stuff.
Probably. But in terms of documents versus, let's say, I mean, just in a very general sense, a document versus a paragraph versus a sentence.
Yeah.
There is like, you sort of, as you grow, you're gaining like meta information.
Yeah.
One document's different from another document, and the language is used differently between the two. But is there anything beyond that how they're treated, like as far as different objects? Is there something larger at work here? For instance, if you did document analysis on 100 documents, and then if I took those 100 documents and stuck every 10 of them together, to make 10 documents, like what's the change here? Going from like small, just basically larger amounts of text.
Yeah, definitely. You're starting to get more like longer amounts of contextual information. I mean, it'll be the same thing then, I guess, if you then like documents have no really set length, but it would be of course different if you're looking at like say like a page document or something versus like a book length document or something like that. Or like